In the last lesson, we found the area formulae for the parallelogram and the triangle. Are you ready to investigate two more shapes? We want to find ways to create area formulas for them using what we know already. By the end of this lesson, you should be able to find the area of the trapezium and the kite. Let's have a look at the trapezium first. We could try to make a rectangle from it, but I'm going to try to make triangles. If we can, then we could use the formula for the surface area of a triangle to find the formula for the surface area of the trapezium. Now, I have a cutout of a trapezium. I'm going to fold this base onto this base here. We want to find the midpoint of the sides. I'm going to take my pen and a ruler and draw a line from this vertex to the midpoint of our side. And we'll take our pair of scissors and cut this triangle. And now we rotate the triangle like this. See what we have? A triangle. Do you want to see that again? Let's have a look at what I've done using a diagram. We start with the trapezium EFGH. It has a height h and two parallel bases EF and HG. I call the length of EF A. I call the length of HG B. Now we fold the base EF onto HG and we mark the midpoint here. We'll call this midpoint point O. FO is equal to the length of OG. Now I can draw in a line connecting E to O so that we get triangle EFO. Rotate triangle EFO around the point O and align FO with OG. Call this point here J. That gives you the new triangle EJH. Great! We've made a triangle from a trapezium. We know the areas of a trapezium and the triangle are equal to each other. We also know that the area formula for a triangle is half the base times the height of the triangle. Can we work this out on our new triangle EHJ? Okay, we know that the area of triangle EHJ is equal to the area of trapezium EFGH. So its formula is area is equal to half base multiplied by the perpendicular height. We know that the base of the triangle is made up of B plus A, so we can write half B plus A multiplied by the height. What do you notice about A and B? They're the parallel sides of the trapezium. So we can write the area of the trapezium as half the sum of parallel sides multiplied by the perpendicular height. By now you should be getting used to changing one shape into another shape, keeping the areas the same. The last and final shape we need to look at is the kite. How do you think you could get from this kite shape to this rectangular shape? Any ideas? Again, I hope you will try this out by cutting paper or cardboard shapes by yourself. This is the best way to be sure that you follow what I have done. Right, here we go. Here I have a cutout of a kite. I've drawn in the long diagonal as well as the short diagonal. I'm going to take my pair of scissors and cut along the long diagonal, like this. Now I'm going to cut along half of the short diagonal. Next, we flip this triangle like this and slide it all the way around to slot in like this. We do the same with this triangle, flip along this line and slide it along. And here we have our rectangle. That was quite fast. I think we need to take a slow, careful look at what I did to get the rectangle. Let's start with this kite. I have labeled it OPQR. We can draw in the diagonals from O to Q and R to P. We'll call this diagonal OQ D1 and diagonal RP D2. I'll mark this point where the diagonals intersect as point S. Now cut through on diagonal RP. Then cut out triangles RSQ and PSQ along the fold line SQ. Flip triangle RSQ over the line SQ like this and slide it up to fit onto OR like this. Let's do it again. PSQ over the line SQ and slide up until QP fits onto OP. Here it is again. And look at what we've made, a rectangle. Let's label it. We'll call our rectangle S, S prime, P, R. Can you see that the area of this kite is equal to the area of this rectangle? We have used the rectangle formula several times now. Do you remember what it is? It is base times perpendicular height. Now using this, let's work out the formula for a kite. We know that the area of the kite is equal to the area of the rectangle, and that the formula for the area of the rectangle is area is equal to base times height. Now in the rectangle, we have a base of PR, which is also the long diagonal of the kite. So we can instead write D2. The height of our rectangle is actually half the diagonal, the short diagonal of the kite. So we could write half of D1. This means that the surface area of our kite is area is equal to D2 times half of D1, where D1 is the first diagonal and D2 is the second diagonal. The area of a kite is half times diagonal 1 times diagonal 2 of the kite. Let's summarize what we've covered in this series so far. We saw that you can take the formula for finding the area of a rectangle, area equals base times height, and use this to find the formula for other shapes. The area of a parallelogram is equal to base times height, where the height is the perpendicular distance between the horizontal parallel lines. The area of a triangle is equal to half times perpendicular height times the base. The area of a trapezium is equal to half the perpendicular height times sum of the parallel sides. Area of a kite is equal to half times one diagonal times the other diagonal. Right, Now it's your turn. Here's a task to see if you've achieved the outcome. Make a flow diagram or a mind map showing the relationship between the different shapes that we have looked at so far and their formulae for calculating area. I love playing with shapes like this. I hope you've had as much fun as I did in this lesson. You should try changing these shapes with your own cutouts. That's all for this lesson. Till next time, goodbye.